So we're going to talk about what it actually means to find a solution to an equation. And we've done equations with just one variable in them before. In order to find the solution, we have to isolate our x in order to be able to solve. So I'm going to take, I've got an x over here and I've got an x over here. I've got to get rid of one of them. So I'm just going to choose to get rid of this one. It's going to leave me with a negative 12. If I subtracted x from over here, I got to subtract x from over there. So now I've got an x minus 3 on the left hand of my equation and a negative 12 on the other side. How do I get rid of that minus 3? Of course, with a plus 3. So x is equal to negative 9. What exactly does that mean, x is equal to negative 9? Hopefully you guys remember. So I'm going to take my original equation. And it means that I can now take negative 9 and put it in for x and make my equation balance out on both sides. So 2 times negative 9 is negative 18 minus 3. Negative 9 minus 12. So look, sorry, alarm was going off. So negative 18 minus 3 is a negative 21. Negative 9 minus 12 is also a negative 21. So a solution to an equation means that you can take the number that you get, or the solution, put it in for your x value, and it'll balance out. You guys saw before when we had equations with just one variable, sometimes there's no solution, sometimes there's an infinite number of solutions, and sometimes there's just one solution, like this case. In this case, x is equal to negative 9, and that's it. But now things are going to change a little bit when you have something like this, an equation that has both an x and a y variable in it. And this is going to be different because it's going to have a lot of different solutions. Our previous example only had one, x is equal to negative 9. But now, x plus y is equal to 3 has a whole bunch of different possible solutions. For example, x could be 1 and y could be 2 because 1 plus 2 is 3. So 1, 2 is one solution. The way we would write that is an ordered pair. Remember from when you learned how to graph that x goes first and then your y goes second. So one solution, because here x is 1 and y is 2, is 1, 2. That means you can put a 1 in for x and a 2 in for y, and it makes this equation balance out. So 1, 2 is a possible solution. Well, x could also be 2 and y could be 1, because 2 plus 1 is also 3. So another solution is 2, 1, where the x is 2 and the y is 1. I could also have decimals. So x could be 0.5, y could be 2.5, because 0.5 plus 2.5 is 3. So another solution could be 0.5, 2.5. So as you can tell, I could pretty much sit here and do this all day long. Because there, I could come up with x could be 0, and then y could be 3, for example. So if x is 0, y is 3, x plus 3 is 0, so 0, 3 is a solution. So when you've got two variables, there are a ton of different solutions that you could come up with. It's also important to notice that after you get these solutions, you can actually use them to graph your equation. Because I know that if x is 1 and y is 2, that one works. I could go over 1 and up 2, so 1, 2 is a point on that line. My other solution, 2, 1, is a point on this line. I'll skip this decimal for a second and do 0, 3. As you can see, they're forming a straight line, which means that they're linear. It's going to be something really important later. I'm going to try to draw a relatively straight line here. So I could just connect my dots. There I go. I've graphed the function by finding different points. I put the arrows on either side of mine because technically I could still keep finding solutions and I could keep graphing more and more points. So I'm putting the arrows on either end to represent the fact that technically down here there's a lot more points on this line, and up here there are a lot more points going in that direction. Now this is a fairly easy solution, easy equation to find solutions to. Usually most teachers will require you to find at least 3 solutions and then just connect the dots in order to be able to graph it. And this one was pretty easy. Now, they're not always going to be that easy, of course. You guys should have been given a handout that says 8.2 at the top of it, and you have a handout that you were asked to find solutions to different equations. And I've actually made a little handout for you that looks like this so that you have space to write. The number 1 on the paper that you're given is this one right here. Y equals 8x minus 4. To try to make things a little bit easier for the first couple, I actually gave you some values for x to use. So to find the solution to these equations, what you're going to do is it tells you that x is 8. So you're going to actually put in here y is equal, instead of 8 times x, you're going to do 8 times 0 minus 4. Well, 8 times 0 is 0. 0 minus 4 is negative 4. So one solution is 0, negative 4. If x is 0, y is going to be negative 4. The next number, and I don't always give them to you, I just decided to do it for this first one. So instead of 8 times x, we're going to do 8 times 1. 8 times 1 is 8. 8 minus 4 is 4. So if x is 1, y is a positive 4. So 1, 4 is another solution. Now I'm going to do y is equal to 8 times negative 1 minus 4. So 8 times negative 1 is a negative 8. Negative 8 minus 4 is negative 12. So negative 1, negative 12. And finally, based on the x values I gave you, instead of 8 times x, I'm going to do 8 times 2 minus 4. So 8 times 2 is 16. 16 minus 4 is a positive 12. So 2, 12 is another solution. So that's all you have to do to find a solution to an equation. You take values for 1, just put them in there for x. So what I want you guys to do is number 2, right here on your paper, I also gave you some values that I would like you to use for x. You pause the video, you try to put your x values in and find out what your y values would be so that you can find some solutions. So go ahead and hit the pause button now. You try it and check this with me in a second. I'm assuming you've already tried it. So I'm doing y equals, instead of a negative x, we're going to do a negative 0. But of course, there really is no negative 0, so it's just going to be a 0. So 0 plus 12 means that y should be 12. So one of your first solutions should be a 0, 12. Next, instead of a negative x, we're going to do negative 1 plus 12. So negative 1 plus 12, y would be equal to 11. So it's going to be 1, 11. Next, instead of putting in a negative x, we're going to put in, now think about this for a second. This is a negative 1. So if I put a negative 1 in for x, it's a negative 1. So what happens when you have a negative number? Those two negatives cancel, and it's actually going to be a positive 1 plus 12, which means that y is going to be 13. So another solution is negative 1, 13. Finally, y equals negative 2 plus 12. Negative 2 plus 12 is 10. So final solution is 2, 10. If x is 2, y has to be equal to 10. Now, whenever you have an equation that is set up like this, that it's like y is equal to the x, it's pretty easy to figure out what x is equal to, because you just put the value for x in for x, and then just figure out what that would make y equal to. Well, of course, they're not always that simple. Because you notice here this time, it doesn't say y is equal to anything. So now we've got to figure out how to isolate and how to get our x solved. So this is how you would do it. First of all, unlike the last two examples where I gave you numbers, I didn't give you values for x this time, so you're going to have to pick them yourself. But that's no big deal. I personally usually like to stick with really easy low ones like this, 0, 1, 2, negative 1, something like that, just because I like that you have to work with smaller numbers that way. So that's what I'm going to do here, although you don't have to do that the same way that I'm doing it, but I'm going to choose some easy ones like 0 and 1 and -1 because I just think that's going to be a little easier. So instead of 4 times x, I'm going to do 4 times 0 minus 4y is equal to 24. So just like we normally did when we had to solve an equation with one variable before, in this opening example that I gave you, that's what we need to do now. We need to get, now that we know what x is equal to, we're putting x into our equation, and now I've got to solve for y and figure out what y is going to be equal to. So 4 times 0 is really just going to be 0. So that's kind of gone now. It's not even there anymore. So now you're just left with a -4y is equal to 24. Well, you know how to solve an equation like that. It's a one-step equation. That -4 sitting next to the y means multiply. We're going to undo that multiplication with division. So y is equal, 24 divided by -4 is a -6. So if x is 0, y is equal to a 6. You go ahead and pause the video now and try the second number. So instead of putting in 4 times x, you're going to put in 4 times 1. And then try to solve for x. So go ahead and pause it. You try it. Try to figure out what y would be equal to if x is equal to 1. I'm assuming that you've already paused the video. So you're going to do 4 times 1 and get 4. 4 minus 4y is equal to 24. Okay, now we've got to get that y isolated so that we can solve for it. So we got to get rid of this 4, first of all, with a -4. That's going to leave me with -4y is equal to 20. Then, to get rid of that 4, I'm going to divide by -4. So y is equal to -5. Because 20 divided by -4 is -5. So another solution is 0, -5. Let's keep this down just a little bit. Last but not least, I'm going to see what happens if I put in a -1. You guys go ahead and try it on your own for a moment. So instead of putting in a 4 times x, I'm going to put in a 4 times -1 minus 4y. Oops. Let's try to write that a little smaller. So 4 times -1 minus 4y is equal to 24. So I've got 4 times -1, which is a -4, minus 4y is equal to 24. You got to get rid of that -4 by adding 4 to both sides. It's going to leave me with -4y is equal to 28. Divide both sides by -4. So then y would equal -7. So when x is -1, y would be a -7. So what's going to make these practice problems a little bit tough is that we can't do really where you just try it yourself and then check the video to check it. Because the problem is going to be that if you don't pick the same numbers that I do, your answers are going to be different. So what I would like to go ahead and do is maybe you go ahead and try the first few and pick 0, 1, and -1 for x. So for number 4, go ahead and do it with 0, 1, and -1 so that you can actually check a couple of them with me. Although normally you can pick whatever value you want for x. I just personally think that 0, 1, and -1 are a little bit easier because you're dealing with smaller numbers. So for 4 and 5, go ahead and use those two numbers, 0, 1, and -1, and then go ahead and check the video with me to see whether or not you did it right. So now, instead of a x minus y, I'm going to put in a 0 minus y is equal to -15. Okay, well that 0 is pretty much going to be bye-bye. So now we've got a -y is equal to a -15. Well, if a -y is equal to a -15, then a positive y is going to be a positive 15. So really, remember, there's technically a -1 in front of that y. So if I divide both sides by negative 1 means that y is going to be equal to a positive 15, because a negative 15 divided by a negative 1 is a positive 15. So one solution, if x is 0, y would be equal to 15. Now instead of x minus y, I'm going to do 1 minus y equal to negative 15. So to get this y isolated, I need to get rid of that 1. I need to get rid of that 1 with a negative 1. So now I've got negative y is equal to negative 16. If I divide both sides by negative 1, like I did up here, y is equal to 16. Last but not least, I'm going to put in a negative 1 for x. So instead of x, it's a negative 1 minus y is equal to negative 15. To get that y isolated, I need to get rid of that negative 1 with a plus 1. It's going to cancel. This is going to leave me with a negative y. Negative 15 plus 1 is negative 14. If I divide both sides by negative 1, like I did up here, that means y is going to be equal to a positive 14. For the rest of the practice problems, I am going to go ahead and pick x values at the beginning of each practice problem and fill in this part of the chart. Again, I usually just like to use like a 1, a negative 1, and a 0 because I feel like they're easier. But you could technically pick whatever you want. If you are going to use my videos, I think I'm always just going to do 0, negative 1, and 1. So you might want to go ahead and use the same ones that I'm using just to make sure that you're doing the process right. If you do that, it's really important. Do not just copy down what I'm doing. Make sure that you are actually pausing the video, taking these values that I give you, trying to put them into the equation to figure out what your answer is going to be, what your solution is going to be, because just sitting here watching me do it isn't really going to help. Pause the video, try it yourself, and then check the video. And remember, you don't have to use 0 and negative 1 and 1 for x values. That's just what I personally like to use because I feel like it makes it easier. So I'm going to put it, hopefully you've done what I asked and you've paused the video. You've tried to work this out yourself. So if x is 0, let's figure out what y would equal. So y is equal, instead of 7 times x, we're going to do 7 times 0 minus 6. 7 times 0 is 0. 0 minus 6 is negative 6. Okay, so now we're going to do y equals 7 times 1. Or I'm sorry, 7 times negative 1. So I'm going to put a negative 1 in for x. 7 times negative 1 is negative 6. I'm sorry, oops. 7 times negative 1 is negative 7. Negative 7 minus 6 is negative 13. Now I'm going to do 7 times 1. 7 times 1 is 7 minus 6. So 7 times 1 is 7 minus 6 would be 1. So the three solutions I picked are 0, negative 6, negative 1, negative 13, and 1, 1. For number 16, here is another. Again, I'm going to pick 0, 1, and negative 1. It's your choice. You can either try to do it on your own or you can pause the video and check it with me. So y equals, so negative 3, instead of negative 3 times x, we're going to do negative 3 times 0. Negative 3 times 0 would be 0, plus 8, we can make that 8. Negative 3 times 1, so I've got a negative 3 times 1, which would be a negative 3, plus 8 would make this a 5. Finally, I've got a negative 3 times negative 1 is 3. 3 plus 8 would be 11. So those should be the, if you use the three values for x that I used, those should be the y values. Now number 7 is a little bit of a tricky one. And I hope you guys will recall from our mini lesson, when you have an equation like this, which means y equals 12, it means that all the way up here at our y-axis at 12, it's going to be a horizontal line that goes straight through the 12. So really, you don't have to do any work to figure out what some points on this line would be. Basically, your y value is always going to be a 12 because it always goes straight through where y equals 12. So your x value could be a whole bunch of stuff. If I chose this point, for example, this is negative 2, 12. If I chose this one right here, it's 0, 12. If I chose this one right here, let's see, 1, 2, 3, 12. So those will just be the three I picked. So I'll do 3, 12, negative 2, 12, and 0, 12. Okay, so when it's a flat line that goes straight through the y, which is what y equals 12 means, your x value really could be anything, and your y value is always going to be a 12. If it were the opposite, let me show you another one. If it were the equation where x is equal to 12, it would be the opposite. It would look like, well, we're going to pretend that this is 12 over. It would be down here where the x is equal to 12 instead. So instead of being a horizontal line, it would be an up and down vertical line. And then in that case, all your x values would be 12. But then your y values could be whatever you wanted. Okay, so now we've got another one. I'm going to use the numbers 0, 1, and negative 1. If you would like to use those values too, pause the video, try it out yourself. Try to figure out what y would equal if x equals these numbers. I'm going to assume that you've already paused the video. Instead of 4 times x, I'm going to do 4 times 0 minus 2y is equal to 0. So 4 times 0 would be 0. So that's going to pretty much be nothing. So negative 2y is equal to 0. If I divide both sides by negative 2, y is going to be equal to 0. So if x is 0, then y was equal to 0. For number 2, instead of 4 times x, I'm going to do 4 times 1 minus 2y is equal to 0. So 4 times 1 is 4 minus 2y is equal to 0. I need to get rid of that 4 with a minus 4. So this is negative 2y is equal to negative 4. Divide both sides by negative 2. Negative 4 divided by negative 2 is a 2. Last but not least, if x is negative 1, instead of 4 times x, I'm going to do 4 times negative 1 minus 2y is equal to 0. So 4 times negative 1 is a negative 4 minus 2y is equal to 0. To get rid of that minus 4, I'm going to plus 4. So I've got negative 2y is equal to 4. Divide by negative 2, y would be equal. 4 divided by negative 2 would be a negative 2. So if x is 1, y is a negative 2. I'm going to put in a 0 for my first number, for negative 9. Please make sure that you have paused the video and you've tried this yourself before you're watching me do it. So instead of 4 times 0, or x, I'm sorry, instead of 4 times x, I'm going to do 4 times 1 minus y is equal to 4. This is going to be a 0, which will just leave me with a negative y is equal to 4. So remember, there's technically a 1 in front of that y when there's no number there. So to get rid of that negative, we're going to divide each side by negative 1. So that means that y is equal. 4 divided by negative 1 is a negative 4. So if x is 0, y is a negative 4. Now let's see what happens if 4 is a 1. So I'm going to do 4 times 1 minus y is equal to 4. So 4 times 1 is 4 minus y is equal to 4. To isolate that variable, I'm going to subtract off this 4 from each side. So that a negative y is equal to 0. Remember, there's technically a negative 1 in front of there. So if I divide both sides by negative 1, y is equal to 0. And now let's pretend that it's a negative 1. So instead of 4 times x, I'm going to do 4 times negative 1 minus y is equal to 4. 4 times a negative 1 is a negative 4 minus y is equal to 4. I got to get rid of that negative 4 with a plus 4. So I've got a negative y is equal to 8. I'm technically dividing both sides by negative 1. So if I divide both sides by negative 1, y is going to be equal to negative 8. For the second half of this worksheet, you should be picking your own points. Okay, so basically starting with number 10, we're doing exactly the same thing that we did here, but the only difference is now we're going to, once we find those different solutions, so here we had like 0, negative 4, and then we had 1, 0, etc., etc. So now, once we have a point on the line, we're actually going to graph it. So I'm going to kind of make myself a little chart over here. I'm going to do a little bit better job of that. So y equals 3x minus 2. So again, I'm going to pick 0, 1, and negative 1 for my x values. So I'm going to do, so y is equal, instead of 3 times x, we're going to do 3 times 0, which is 0 minus 2. So 0 minus 2 is negative 2. So that means when x is 0, y is a negative 2. So that means that 0, negative 2 is 1 point on that graph. So now I'm going to do y is equal. 3 times x is going to be 3 times 1. So 3 times 1 is 3 minus 2 is going to be 1. So that means that 1, 1 is another point on the line. So I'm going to go over 1 and up 1. Last but not least, I'm going to do y is equal to 3 times negative 1 minus 2. 3 times negative 1 is negative 3. Negative 3 minus 2 is negative 5. So negative 1, negative 5 is going to be a point. So 1, 2, 3, 4, 5. I know, and you're going to find out later why, but I will tell you for the purposes of this worksheet, I know that I'm right, and you guys will know that you're right when you're graphing these if they form a straight line, just like so. So I connected my dots, added my arrows, because technically I could add more points up and more points back. So this is exactly what you're going to do for the other examples. You're going to pick values for x that you want. You're going to put them in and figure out what the y value would be. Then you're going to graph those 3 points. And even if you don't choose the same points that I choose, the line still should look the same. Although I recommend sticking to these small ones, the 0, the 1, and the negative 1. But you certainly don't have to. Okay, so for this one, I've got y is equal to negative x plus 3. I'm going to do what I've been doing, and I'm going to pick 0. Go in for x first. So 0 plus 3 means that y would be equal to 3. So my first solution, if x is 0, y is 3. So one solution is 0, 3. So my first point, I don't go left or right, but I do go up 3 because that is 0, 3. For my next point, I'm going to choose a negative, I'm going to choose a 1 to go in for x. So negative 1 plus 3. Negative 1 plus 3 is 2. So if x is 1, which is what I put in, y is going to be equal to 2. So the solution 1, 2, so over 1 and up 2. I'm going to choose negative 1 to go in for x last. So instead of y is equal to negative x plus 3, I'm going to put in a negative 1. Now, so it's really a negative, negative 1. So what happens when you put in a negative, negative 1? It actually becomes a 1. So it's really going to be 1 plus 3, which is going to be a 4. So if x is negative 1, my y is a 4. So I'm going to go over negative 1 and then up 1, 2, 3, 4. I know I probably did it right because it's in a straight line, and that is actually what it's supposed to look like. This one's a little bit of a pain because of those fractions, but it still should be okay. It's not too bad. First thing to point out is that I still do exactly the same thing. I'm going to make myself, I should have made a little chart on the last one, and I didn't. I should have. Okay, where you got your x and your y. I've got my equation here in the middle. Y equals negative 1/2 x plus 3/2. And you guys are allowed to use a calculator too, so that should be helpful as well. Make sure that you are trying this yourself first, then you're going back and checking it with the video. So you should already have some answers on your paper. First one I'm going to choose a 0 for x. So y equals 1/2 times x is just going to be, or I'm sorry, 1/2 times 0 is just going to be a 0 plus 3/2. So 0 plus 3/2 means that y is 3/2. 3/2 simplifies to 1/2. So my first point is 0, 1/2. So here's my 0. Then I'm going to go up 1, and then like a little half right there. So that's 1 point on my line. Now I'm going to pick a 1 for x. So I'm going to pick, so 1/2. Instead of 1/2 times x, it's going to be 1/2 times 1 plus 3/2. So negative 1/2 times 1 is just a negative 1/2. Negative 1/2 plus a positive 3/2 is going to give you positive 2/2, which simplifies to a 1. So if x is 1, then y is going to be 1. So I go over here and I graph over 1 and up 1. Then I'm going to put in a negative 1 for x. So instead of y is equal to negative 1/2 times x, it's going to be times negative 1. So negative 1/2 times a negative 1 is a positive 1/2 plus 3/2. 1/2 plus 3/2 would be 4/2, which simplifies to a 2. So x is negative 1, y is a 2. So I should go over to the left 1 this time because it's a negative 1. Up 2. You can see they form a straight line. So I've probably done it correctly. I'm going to set up here. So instead of a y equals negative 2 times x, it's going to be a negative 2 times 0 minus 5. Negative 2 times 0 would be 0. 0 minus 5 is a negative 5. So 1 point on my line is a 0, negative 5. So I should go 0 and then down 1, 2, 3, 4, 5. Instead of y equals negative 2 times x, I'm going to do negative 2 times negative 1. So negative 2 times negative 1 is a positive 2. 2 minus 5 is a negative 3. So 1, 3 is going, or 1 negative 3 is going to be another solution. So go over 1 and then down 1, 2, 3. And last but not least, I've got y equals negative 2 times, I just picked 2 this time just for something different. So negative 2 times a positive 2 would be a negative 4. Minus 5 is going to be a negative 9. So I would go over 2, because it's a positive 2, negative 9. So I go over 2 and then down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means I did something wrong. Oh, now I see. Sorry, it took me a minute to figure out what the heck I did. So the reason that I knew that I made a mistake was because by the time I go over here 2 and then down negative 9, this isn't going to form a straight line. And so I knew I did something wrong. So then I realized I got to go back up here. This is where I goofed. I wonder if you guys noticed that at home. So instead of doing negative 2 times negative 1, I should have done, so what I really did was negative 2 times negative 1, not the positive 1 that I originally said. So when I'm graphing it, it should be a negative 1, negative 3 instead. So over negative 1, there we go. So then when I graph 2, negative 9, which will be down here-ish, they do form a straight line. So it happens to the best of us, folks. Be really careful and make sure that you don't goof. So again, what I did is I meant to put a 1 in here, but I actually put a negative 1 in there. So my solution wasn't a 1, negative 3. It was a negative 1, negative 3. Number 14. So I've got y is equal to 4x minus 8. I'm going to put in a 0 for x. So 4 times 0 is 0. 0 minus 8 is a negative 8. So 0, negative 8 is going to be one solution. So I don't go up or down, but I go down here to 0, negative 8. Notice my scale is going up and down by 2 this time. So now I'm going to pick 1. So y equals 4 times 1 minus 8. 4 times 1 is 4, minus 8 would be a negative 4. So my next solution would be 1, negative 4. So I'm going to go over 1 and then down to the negative 4. Last but not least, let's just use a negative 1. So y equals 4 times negative 1 minus 8. 4 times negative 1 is a negative 4. Negative 4 minus 8 is a negative 12. So I'll go over. So negative 1, negative 12 is another solution. So go over to the left, negative 1, and then down to the negative 12. They do form a straight line. Well, as straight as I'm graphing it anyway. So I know I probably did it right. So now that we've done several of these the long way by plotting points, I want to show you guys that there really kind of was a shortcut we could have been using the whole time. It's important that you guys know for the next activities how to plot points, but I'm wondering if anybody noticed that every one of these equations so far, every one of these is in the format where it has y equals a number times x plus another number. I wonder if that sounds familiar to you. So remember, whenever it's like that, this is called slope-intercept form, where this is the slope of your line, and that is your y-intercept. So really, all this time, instead of doing all this work where you plot points and put 0 in for x and figure out what y is equal to, you could have just used the fact that this is in slope-intercept form. So this tells you your y-intercept is a negative 2, which means it's going to hit the y-axis right there at a negative 2. Remember that your slope is your change in your y over your change in your x. So this is telling you it's going to go up 2 and then over 3. So you literally count up 2, over 3, down 2, over 3. So because that was in slope-intercept form, it sure was a lot faster to graph. Now you try this last one. Remember that if you want to look at it in slope-intercept form, it is technically in slope-intercept form. Even though there's no number hanging out to the side like there was in the previous example, remember that a plus 0 means that the y-intercept is a 0. So if there's nothing there, we assume that the y-intercept is a 0. This means our slope, negative 5, is the same thing as negative 5 over 1, which means we're going to go down 5 and then over 1. So from our y-intercept of 0, we're going to go down 1, 2, 3, 4, 5, and then over 1. And voila, we've graphed that function too. If you wanted to do it by just graphing the points instead, look, it's going to turn out to be the same thing. So y is equal to negative 5x. So if I put 0 in for x, that means that y is going to be negative 5 times 0 is a 0. So 0, 0 is 1 point. If I put in negative 5 times 1, that's going to make y a negative 5. So the next point will be 1, negative 5. So over 1, 1, 2, 3, 4, 5. So you notice I still get the same points that I did when I did it the slope-intercept form way too. Either way, works out to be the same.